Hey, it's Mr. Lineski here with Unit 1, Section 3. This is the last video of Unit 1. We are going to be looking at types of angles and angle addition today. Lots of vocabulary here, so please make sure that you are using the pause feature to make sure that you are kind of writing down, but also listening to what I'm talking about as well. Alright, let's get started. So I actually would like that you just start by pausing the video and just writing this stuff down. Alright, fantastic. Now that you have that written down, let's talk about what an angle is. An angle is when you have two rays that have the same endpoint. So we talked about a ray and how we have an endpoint. We call it A, and then it extends in the direction of B. So that's one ray, and if I have two rays with the same endpoint, so A is my endpoint, and let's say I have a second ray with endpoint A, that creates an angle. There are two ways we can name this angle. You always want to go sort of in the order that you were to draw it. So it would be angle BAC or angle CAB. The key to naming an angle is that the common endpoint here, A, is the common endpoint. That should always be in the middle when you're naming your angle. And your angle should always have three letters to it. Alright, in case you ever talk about a numerical value about an angle, you want to put a little m in front of that symbol, so the measure of angle BAC could equal 80 degrees. An angle bisector is when you have a ray that divides an angle in half. Anytime you hear the word bisector, I want you to think of cut in half, two equal parts. So when I cut something in half, I have two equal parts. Whoops, I have that written right here. So if I had an angle, let's say that it was angle DEF, so angle DEF, and let's say that it was 40 degrees, and then I had an angle bisector, EC is an angle bisector. All that means is that I cut this angle in half, and now I have two little parts, DEC and CEF, that are 20 degrees each. An acute angle is any angle whose measure is between 0 degrees and 90 degrees. So that just looks something like this, and I can say 70 degrees. That's acute. An obtuse angle is any angle whose measure is between 90 and 180 degrees. So that might look something like this, and I can say that's 110 degrees. There is also something I forgot to write in the notes called a straight angle. A straight angle is something that equals 180 degrees, and it's exactly what it looks exactly how it sounds. A straight angle is basically just a straight line. So the degree measurement of a straight line is 180 degrees. Alright, moving on again, just take a moment, pause the video, write this stuff down. When you're finished, come back and we will explain these words here. So a right angle is an angle whose measure is equal 90 degrees. We briefly talked about that with Pythagorean theorem. Remember, this little box here indicates 90 degrees. Complementary angles are two angles whose measures have a sum of 90 degrees. So anytime I'm talking about sum, I'm talking about that they add up to 90 degrees. There's two ways that that can be presented. You can have two separate angles, kind of like this, and you can say, oh, these add up to 90, so they must be complementary. Or you could have something like this, where I don't know the measures of these two angles, but I know that this big angle here is 90 degrees. So these two little angles, this one and this one, should add up to equal 90 degrees. Supplementary angles are two angles that add up to 180 degrees. So basically same kind of idea, that I can have two angles. Let's say I have one like this and one like this that add up to 180. Kind of a nice little trick to remember which one is which is complementary 90 or 180. The letter C in the word complementary, if you just draw a line down, you kind of make the number 90. And so you can go, oh, that's 90 degrees. Adjacent angles are two angles that share a common ray. So they share a ray. If you ever have been in a hotel and you get a room next maybe to your family or your friends and you ask for adjacent rooms, those are just rooms that share a wall. So they're sharing this ray, this angle here, and this angle here. So like angle 1 and angle 2 would be equal. or I'm sorry, not equal, would be adjacent. A linear pair are two adjacent angles that are supplementary. So remember, supplementary means 180 degrees, but they have to be adjacent. So that means two things. They share a wall, and they add up to 180. Basically, when you are looking for a linear pair, you are looking for that straight angle. You're looking for a straight line, and then typically there's some ray that comes down like this. If you ever see me drawing a little half circle like that, that's to just indicate that these two angles are a linear pair. So anytime you have a straight line with that ray coming through, that is a linear pair. This concept and this concept are two of the most frequently visited concepts in this class, linear pairs and vertical angles. So please make sure you have a solid understanding of these two things. Vertical angles are two angles whose sides form pairs of opposite rays. It sounds really confusing, but basically it is just two lines that intersect at a point, and then the angles that are formed, so right now I have four angles. I have angle 1, 2, 3, and 4. Those create what are called vertical angles. So a pair of vertical angles are the angles that are opposite of each other. And so angle 1 and angle 3 are sort of across from each other. And the idea behind vertical angles is we can say that these two angles are equal. Now, a word that we use in geometry is congruent. This symbol right here is the congruent symbol, and it basically just means that they have the same measurement. We use congruent when we don't know what the actual measurement is, but we can say that they're the same. So even though I don't know what the measurement of the angle is, I can at least say, hey, 1 is equal to 3, or is congruent. I can also say that 2 is congruent to 4, because those are also vertical angles. Angle 4. And then finally, last vocab word here is interior. Interior is just something that goes on the inside. So if I had an angle here, and I said that it was angle ABC, and I told you that point D was interior to that, that just means it's inside this angle. So you would put point D here, and then you can kind of draw that line. All right, looking at some example problems here, I'm just going to give you some hints and things as we go through these. First problem, we have this nice big figure here with different numbers for the angles, 1, 2, 3, 4, and 5. First question is name a set of complementary angles. So remember, complementary means it adds to 90. So you wouldn't want to say angle 1 here, because angle 1 is just one angle that is already 90. It's not two angles that add to 90. Whoops. Sorry, that's on your notes there. So if you look, we have our little box here indicating 90 degrees. And so I can say that angle 3 and 4, even though I don't know what the measurements are, I know that they would add up to 90 because it has that little box there. Name a set of vertical angles. So remember what you want to look for here. You want to look for intersecting lines, which if you take a look at the figure, here's a line here, and here's a line here. I want to use those two lines. I wouldn't want to use this because it doesn't actually intersect the whole way through. So when I create those two intersecting lines, I have a nice pair of vertical angles right here and right here, angle 4 and angle 5. Name a pair of supplementary angles. So remember, supplementary means that they add up to 180 degrees. And so what you might want to look for there is a straight line, because remember, a straight line adds up to 180. So here's a nice straight line right here. I can say angle 5 and angle 2. Cool thing is that angle 5 and angle 2 are also a linear pair because they share that wall and they're on a straight line. Another example of a linear pair here, I could look at this straight line here, this blue one, and I could say 4 and 2 are a linear pair. So either one of those works. So then this question, are angle 4 and angle 2 adjacent? Explain why or why not. So keep in mind, adjacent just means that they share a ray, they share a wall. So here's angle 4, here's angle 2. They share that wall right there. So we would say yes. The reason why would just be they share array. Alright, next question here involves a little bit of angle bisecting and a little bit of algebra. So if I have this angle here, it says BD bisects. So remember, bisects means cut in half of angle ABC. So this is cutting angle ABC in half, and then it says angle ABD is 2x plus 3. So ABD is this angle here. And then we're told that DBC is this angle here, is equal to 3x minus 13. And so we want to find the measure of angle ABD. So if you actually take a look here, if it's bisecting, what you need to remember is that it means that these two parts are equal. If it's cut in half, two equal parts. So all we're going to do for this is set these two parts equal to each other, and then solve for x. So I'll subtract 2x from both sides, giving me 3 equals x minus 13, and then I'll add 13 to both sides, giving me x equals 16. What you need to be careful about in geometry is oftentimes we're not just solving for x, we usually have to go back and substitute in. So make sure you substitute 16 back into ABD. So ABD was this thing here. So now we substitute 16 in. And when we solve that, we get 32 plus 3, which is 35 degrees. Alright, the last little bit here that we're going to talk about is angle addition postulate. Last video we talked about segment addition, which was part plus part equals whole. This is the same exact thing except with angles. So if I have something like this, and I break up that big angle into two little pieces, let's say angle 1 and angle 2, I can say that angle 1 plus angle 2, and let's say this big angle here was angle 3, is equal to angle 3. That's all the angle addition postulate says. So here's where it's really important that you understand how to read angles and identify what they're talking about. So this says given that angle ABC is 20x. So angle ABC is the big angle. It's this whole thing. So that's my whole, 20x. And then CBD is this piece right here. That's equal to 13x. So that's a part. And then this section here, ABD is 5x plus 10. That's the other part. And so all I'm going to do here to solve is part plus part equals whole. So 5x plus 10 plus 13x equals 20x. And then just simplify and solve. So combining like terms, subtract 18x from both sides, giving us 2x. And then when we divide both sides by 2, we get x equals 5. But keep in mind, we are not just solving for x. We need to go back and solve for angle ABC, which is this piece right here. So substitute that 5 in for x. 20 times 5 is 100 degrees. All right, this last question here I would like you guys to try on your own. Thank you for watching. I know it, and now you know it.